So the Year 7 Working with Numbers test. Let's go through this one by one until the end. So make sure I've got my name on it. Now, first question says the place value of 6 within this number. I've got a neat little trick, which is I just kind of put little arrows above the 6. I write 6, and then for every other number, I just write a 0. Then I just have to read this number. I can see that this 6 with 3 zeros is 6,000. So I'm just going to look, and my answer here is D. Next question, question 2. Using numerals, so writing it out as a number instead of words, we have 35,016. Now, instead of writing it out like this, or like this, these numbers 35,000, and then we have 16 on the end. So we're just going to look for this in our list, and this is going to be B. Our next one, we've got 8 times 1,000, which would make 8,000. We've got 2 times 100, which would make 200. And we've got 5 times 1, which would make 5. So if we just add up these columns, 5, add this one up, 0, get this one up, 2, and then we have 8. And that makes my answer C. This one, the same trick as before, works, but it's a bit of a bigger number. We've got 7, 0, 0, 0, 0, 0. So this number, 7, and then 5 zeros. Well, if we have 3 zeros, that's 1,000, and we've got 700 of them. So we've got 700,000. So this is 700,000, so my answer is C. Which of the following numbers is not a prime number? Now, prime numbers you might need to look back over in your factors section, but they're a really important part of maths. So essentially what this means is it has factors of 1 and itself. And that's all it has. So when we think about the number 15, well, we can make the number 15 with 3 times 5, or we can make it with 1 times 15. This means it's not prime because we have this here. Okay? So actually, if we look at all these other numbers, 19, the only way that we can make 19 is 1 times 19. There's no other way. 2 times, no, it just doesn't work. So the only one that is not a prime number, because 13 can only be made by 13 times 1, the only one that is not a prime number is 15. And 15 is actually what we call things that aren't prime numbers. It's actually a composite number. So, there we go, our answer is C. That's the only one that wasn't prime. Moving on. The product of 22 and 55. Well, product, this is just a posh way of saying times. So actually what this question is asking is 22 times by 5. So I can do this however I like. I can use mental methods. So I can think, well, this is 5 times 20, which is 100. And 5 times 2, which is 10. When I add these two together, I get 110, and there's my answer, which is D. The quotient of 10 and 2, well, quotient, if we think of quarters, if we think of dividing, we're going to get the quotient of 10 and 2 is like saying 10 divided by 2. Now, if I had $10 divided it between 2 people, that's $5. Done. A. Now, the remainder when 5,092 is divided by 8 is what? Now, this one's a bit more unusual for me. Even though this is going to take a minute or two, I'm actually going to do my long division algorithm just to make sure. So I've got 5,092 and 8. 8 into 5 goes 0 times, and I have 5 left over. 8 into 50, well, that's going to go 6 times with 2 left over. I'm done with that. 8 into 29. That's going to go 3 times with 5 left over. And 8 into 52 is going to go 6 times with 4 left over. So I've got a remainder of 4. This is going to come up later, so I'll need to use this technique a couple of times. When 786 is rounded using leading digit approximation, well, the leading digit, if you're leading on a table, on a competition, if you're leading, you're in first place. So the first digit, so the leading digit in 786 is 7. So if you're using leading digit approximation, well, this is actually... So as 7 is our leading digit, we have to take a look at our next digit along. And all we need to think is this number above 5 or larger? Well, yes, it is. If that number's 5 or larger, what we actually do is increase the size of this number. And then we turn everything else into zeros. So increasing the size of this number makes it 8. And then we just add in zeros. So actually we get 800 through leading digit approximation. Again, if rounding is something that you're not very confident with, you can have a look at that section in the OneNote. So, moving on. This is now looking at BODMAS or BIDMAS. This is the order of operations. So what we need to do is we need to obey what this says to do. Now BODMAS says for us to do brackets first. So the very first thing I'll do here is 9 take 4, which is 5. So the equation I'm basically left with is 3 times by, and I've got a bracket, 8 divided by 2, plus, and because I've done that bracket now, this is just 5. So the next thing that I'm going to do is actually this thing, because it's inside this bracket, which I must do first, and then within that bracket, I still follow BODMAS, so I do this. What I'm going to get there is 4, and now my equation basically looks like this. I still need to do my bracket first, so I'm going to do this. And I'll get 3 times by 9, which is 27. Beautiful. Now, this is a really easy one, and kind of a giveaway. Whenever we have this, where a number's repeated with only time signs in between, all we have to do is count them. 1, 2, 3, 4. And then that number jumps up to the top. So, 5, 4 times. So, our answer is B. Now, this one is a bit weird, but a multiple implies basically a times table. So we could actually look at our times table grid even to help along with this. Which one sticks out as odd? 8, 16, 24, 36, and 40. Well, if we look at the 8 times table, that goes 8, 16, 24, 32, and 40. So actually, the one that sticks out as wrong is this 36 here. It should actually be 32. So our answer there is D. That's all of the multiple choice section. So now we're on to these short answers. I do short answers in the same way I do multiple choice, in that I try and find out the answer. I don't try and have a guess based on what's there. So this should feel no different. Complete set of factors of 48. So factors are what divides into it. Now in class we discussed the best way to do this is writing out all of the multiples that we can. So 1 times by 48. This gives me my first 2 factors, which are 1 and 48. Then I think, okay, well 2 is going to divide into it. So I have 2 and 24. This gives me my next 2 factors, 2 and 24. Then I have to think, does 3 divide into it? Now, if I'm unsure of this, I can always use my divisibility tests, which again is a section on the OneNote. But what I can do is add 4 and 8. This is 12. This tells me, because this is in the 3 times table, it means that 3 will divide into it. So now I have to think, what does 3 times by to make 48? Well, I can think there's 10 3s and 30. There's 6 3s and 18. So actually I have 16. Next one, 4. 4 actually fits in as well. This is in the 4 times table. This is 4 times 12 is 48. 5 doesn't fit in because it doesn't end in a 0 or a 5. So then I've got to think 6. Now 6 times by 8. That's again in the times table. 6 times 8 is 48. So all my factors are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. So it's quite a lot of factors, but there we go. Find the highest common factor and the lowest common multiple of 27 and 36. So this is a big question. This is worth a few marks here. So we've got to think. Let's break down 27 and 36 into their factors. So if we have 27, this is going to break down into 3 and 9. Then it's going to break down again and become 3 and 3. So this is how we're looking. Now 36 is going to break down into 12 and 3. And then this is going to break down again. So I have a factor of 6 and 2. The 2 stops here, and then this breaks down into 3 and 3. Oops. No, it doesn't. No, it's the 2. So now all we have to do is pair up. This is to find the highest common factor. If we look across both of these diagrams to a pair that appears, there's a 3 here, and there's a 3 here, so they're paired up. Okay, and then there's a 3 here, and there's another 3 over here. Now that's the most that we can pair up. We can't pair up one of the 3 with a 2. We can't pair these 2's up with themselves. They have to be from different numbers. So what we actually have is 2 3's. So essentially what we do is we take this number and this number, whatever we've got in pairs, we times them, 3 times 3, and we get 9. That, amazingly, is the highest common factor. So we're done with that first part of the question. Now the lowest common multiple is a little bit more different. There's a few techniques that we can use to find this, but the most simple one is to try and write out, as frustrating as it may be, is actually to try and write out the times tables of these two numbers, and it does happen quite quickly. Because if we think 27, and then 27 times 2 is 54, we add another 27, we get 81, we add another 27, we get 108. 36 times by 2 is 72, add another 36, and we get 108. So this is the lowest number that's a common multiple of these. Again, if you've struggled with this, you can have a look through the HCF and LCM section in the OneNote. But this concept is a little bit more unusual, especially with large numbers like 27 and 36 that we don't know the times tables of. Certainly, most of us don't. Now, this one was a really easy mark. The first 6 multiples of 9. Well, most people did actually get this, but the first 6 multiples, 9 is a multiple of 9. It's 9 times 1. Then 9 times 2 is 18. 9 times 3 is 27. Then 36. Then 45. Then 54. Seeing as you were allowed a times tables grid during the test, this one should have been fairly straightforward. It was just understanding what multiples is. Okay, so we're now onto these algorithms. So, question 2 of the short answer section is getting us to use some of our algorithms. Now, as we discussed in class, with algorithms, you can kind of use whatever you like. If you can do that in your head, then go for it. But I'm going to use the really sort of standard ones that I use all the time and that I sort of spoke about in class. So, what I'm going to do here, this is a subtract. So, if I want to do 4 take 6, I can't do it in this instance. I need to borrow. So I'll borrow. This 8 will become a 7. This 4 becomes a 14, and I do 14 take 6. This is 8. Then I do 7 take 1. This is 6. And my answer is 68. This next one is some addition. 7 plus 9 is 16. I carry my 1. 2 plus 0 plus 1 is 3. And 5 plus 3 is 8. So I get 836. This next one is another minus. What I'm going to do here is I try and do 0 minus 3. In this case, that's going to give me a negative number, so I can't do it. I borrow, this becomes 10, take 3, I'll get 7. Then I go to do 0, take 4. I can't do this, but I can't borrow from here either. So what I actually get is this weird situation where I borrow from here, this becomes 10, and I borrow from here, and this actually becomes 10, and this becomes 9. So I actually have 10, take away 4, which is 6. I have 9, take away 7, which is 2. And I have 3, take away 1, which is 2. That one gets a little bit messy, but it's no different really to a normal one. So, next thing, multiplication algorithms. Again, we can use whatever we like. I know a lot of you guys know this one, which is sort of 8 times 3 gives you 4, and then you have the 2, and then you do 8 times 6, which is 48, plus the 1, and you get 504. But for one like this it's going to be really messy. So what I would actually do for this one is get a grid out like this. Alright, now this was something that I went through in class, but I'll do it again here anyway. So I have 5,037, and I have 74. And what I'm going to do is, a lot of my times tables are coming up in this. So I can look through this and go, okay, 7 times 7, that's 49. 7 times 4, 28. 3 times 4, 12. 3 times 7, 21. 0 times 7, 0. 0 times 4, 0. 5 times 7, 35. And 5 times 4 is 20. If I do a little dashed line, here, this is going to really help with my next step, because I'm going to be coming at it this way. So, I look here, I've got 8. I look here, and I've got a 9, 2, and a 2. So I'll add those up. 9 plus 2 is 11, plus 2 is 13. So I get 3, and I carry the 1. Then I get 4 plus 1 plus 1 plus 1. So that's 4, 5, 6, 7. Then I look here, and I've just got 2 in this column, which makes it nice and easy. Then I look down this column, I've got a 5 and a 2. That's all I've got. So I'll just get 7. Then in this last bit here, I've just got a 3. So my answer is 3, 7, 2, 7, 3, 8. Done. So this says using the short division algorithm, but really I can use whatever I want. I don't have to use short division. If I know that 78 divided by 5, if I know my answer already, I don't need to do much with this. I could actually just jump straight to my answer, but let's just pretend and let's go along with this. So 5 into 78. 5 into 7 goes once. I have a remainder of 2. 5 into 28 now. Well, that goes 5 times with a remainder of 3. So there's my answer. Same thing again here. 1493 goes under the bus stop. 6 goes outside. 6 into 1, 0 times. I've got 1 left over. 6 into 14 goes twice. I've got 2 left over. 6 into 29. Well, 6 would go into 30, but actually I can only go 4 times here. I'm going to be left with a remainder of 5. So 6 now into 53. Well, I know that 6 times 8 is 48, and I'm going to have a remainder of 5. So there we go. Rounding to the nearest 10. So whenever I'm rounding to the nearest something, I think about my columns. This column is units. My next column is tens. My next column is hundreds. So if I'm rounding to the nearest 10, I'm looking at this 5. And what's going to happen is this 5 is either going to stay as a 5 or it's going to become a 6. And that all depends on its buddy to the right of it. In this case, whatever it is, as long as it's above a 5, this 5 is going to become a 6. So this becomes 2, 9, 3, and this 5's become a 6. Then the rest just becomes zeros. So 2, 9, 3, 6, 0 to the nearest 10. The next question is to do round to the nearest 1,000. Now, if I think of my columns, units, tens, hundreds, thousands. So I'm looking at my 9. So if I look to my buddy next to it, is this 9 going to stay as a 9, or is it going to actually go up and basically become a 10, which would make the whole thing 30,000. Well, actually, because this is a 3, it's not going to change it from a 9, but everything else is still going to get wiped out and become zeros. So what we get is 2, 9, and then we just get 0, 0, 0. So that's to our nearest 1,000. If you think about this less mathematically and more in real life, if you had this amount of money in dollars, if you had $29,356, if you rounded it to the nearest 1,000, that would be $29,000. We can kind of do these things quite quickly in our head. If you had $56, to the nearest $10, you've got $60. It's sometimes useful in these situations to think of it as money. Well, I like to think about money anyway. So, use order of operations. This is another name for BODMAS. And this is a real classic kind of question with this. This is one that will actually trick some adults that don't know about BODMAS. But again, you can look back over your notes if you need to remind yourself. But BODMAS says that multiplication is going to become before addition. So, we do this multiplication first. We get 3 times 6 is 18. We plus the 7, so we get 25. Cool. Next one. Now, again, BODMAS. I'm going to work my way through it. B is the brackets, so I'm going to do this first. I'll get a 9 there. I'll keep everything else the same in the same place. Now, what's the next thing that's going to happen? Well, division and multiplication actually happen kind of at the same time. And these two here, that means that we're just going to read from left all the way to right. So, 4 times 9 is 36. We keep everything else in its place. Then we're going to do the 36 divided by 6, which is 6. And we're going to get 9 take 6, which is 3. The most common incorrect answer here was actually people got to this point, but then for some reason right at the end they did 6 minus 9 and called the answer -3. Oh dear. So, there we go. Simplify the following expressions by writing them in index form. Well, all these time signs in between are really helping me out to simplify this expression. Because actually what I can do is just look at how many 3's I've got and use that trick from before and just say, well, actually I've got 3 to the power of 4 because I've got 4 of them. Then I've got 2 5's. I can just put a time sign between and say 5 squared. Next one, nice and easy. I'm going to look at my 2's first. I'm going to start with my smallest number. I've got 2 of them, so I just write 2 squared. Next one, I've got my 7's. So I write 7 squared. Next one, I've got my 11's. So I write 11 cubed. Done. Expand and evaluate. So a lot of the mistakes here was because people were expanding. They were saying 4 squared is 4 times 4. And then they were saying this was 3 times 3 times 2 times 2 times 2. And then they were moving on. But this and evaluate means that I actually have to figure out these numbers. Well, 4 times 4 isn't so bad. It's just 16. This one, 2 times 2 times 2, this is 8. 3 times 3 is 9. So we get 9 times 8. We can look at our times tables grid. We get 72. Cool. Now this seemed to throw people off because this felt like a new symbol, but we went over this in class when we were looking at indexes, if you want to look back through that section. But the square root of 49, this says what number, when it's squared, makes 49. Well, we kind of just spoke about that before, but basically 7 times 7 would be 49. This means that the square root of 49 is 7. So, square root of 49, this is 7. 5 squared means 5 times 5, which is 25. So we get 25, take away 7, which is just 18. Done. Now, moving on to the extended response here. Really, this was interpreting how well you were reading the question. understanding odometers and car things, it's just using a lot of large numbers. But really what they were asking you here, when the driver stops for lunch, the odometer, how far the car has travelled, is 37,018. And when he started, he was on this. So if we want to find how far he's travelled, we can do this number, take away this number. So we can use an algorithm for that. We can say 37018, take away 36794. Line underneath, 8 take 4, 4, 1 take 9, can't do it. Can't borrow from here, need to go 6. It's 10 becomes a 9. 11 take 9 is 2. 9 take 7 is 2. 6 take 6 is 0. 3 take 3 is 0. So, how far has the car travelled? It's 224 kilometres. What will the car's odometer read if the car then travels a further 52 kilometres? Well, right now it reads 37018. So if it travelled another 52 kilometres, this would just add 52 to this number. So 8 plus 2, 0, carry the 1, 1 plus 5 plus 1, 7, and then all of this just drops down. So my answer will be 37070 kilometres. What was the total distance of the journey? Well, he's travelled 224, and then he's done another 52. So we can just add these up. 276 kilometres. The car uses 8 litres of petrol per 100 kilometres. Round the total distance of the journey to the nearest 100 kilometres in order to estimate how much petrol the car has used during its journey. Well, if we look at the journey here, we've got 300 kilometres to the nearest 100. So 300 kilometres, and it uses 8 litres for every 100. Well, we've got 3 100s. So that means we've got 3 lots of 8 litres, which gives us 24 litres. Beautiful. So this final question, to be honest, the first thing that I'd do is kind of lay out what we can know. We know that one of these two numbers has to be a 0, and considering that this one's an 8, that means this one's a 0, which means we know that this is 8. But the most confusing part of this is something times by 3 has obviously given us an 8 here. Now, something times by 3 to give us something ending in 8 must be 3 times 6, but this would have given us 18, which means we would have written 8 here, and then we would have written a 1 here. Even though this is a 5, there would have been a 1 here that got added to it, which means it must have been a 4 before it became a 5. So this number is going to have come from our 6 times by this. So we need to look at this and think, what was 6 times by something to give us a 4 in the end? So, well, 6 times by 4 is 24, and this will give us a 2 here. Then we think 6 times by 1, this gives us 6 plus that 2, so we get an 8. So actually this is how it looks. 858. Okay, so this last bit, we've got our 143, we've got our 16, so we just need to pretend this is a normal multiplication at this point. So 1 times 3 is what makes this 3. 1 times 4 would make this a 4, and 1 times 1 would make this a 1. 0 plus 8 makes the 8, which we've already done. 5 plus 3 makes 8. 8 plus 4 makes 12, carry the 1, and that makes a 2. So there we go. It's a little bit weird to get your head around questions like this, and that's why it occurs at the end of the paper. It's because it's meant to be a little bit of a challenge and make you think in a slightly different way.